Hello, I'm Hussein,
And I'm Omar.
and this is a summary of our final research report.
First, let's introduce our dataset. For this project, we have decided to analyze a small random sample from the Free Music Archive. The dataset is divided into three tables: tracks, genres, and features. The tracks table mainly serves to identify the specific elements of each individual track. The genres table provides specific information about each genre, and the features table defines 8 possible features any song can have and assigns to each track in the sample a numerical value for how each song performs on every one of these 8 features. We will mainly be analyzing the relationship between features and track genre.
During our analysis, we have 2 questions we want to answer. This is our hypothesis question and our prediction question. Looking first at the hypothesis question, the question we wanted to explore with hypothesis testing is the difference in danceability between folk and hip-hop in the sample due to chance as a result of random sampling, or does it reflect something in the population? From this, we can form our prediction question. Assuming that there is a difference, can we predict the genre of a song based on its features? Before starting hypothesis testing, we will explore our data first.
Now, let's explore our data. We have joined the tracks and features table together and selected the values we need to create the table on the bottom left, which we titled Folk Hip Hop. The 2 histograms above that show that the mean danceability for folk seems to be less than that of hip hop. This can be confirmed by the bar graph on the bottom right. The aggregated data table on the top right shows us that there are slightly less folk songs than hip hop songs. This could lead to a potential bias in the data. The average danceability in the table is visualized by the bar graph below, confirming that hip-hop has a higher average danceability than folk in the sample. Let us now move on to hypothesis testing to find out if this is random or if does this represent the population. Let's start our hypothesis test. We used an A/B test since we want to conclude something about one genre being more or less danceable than the other on average. Our test statistic is the average danceability of hip-hop minus that of folk music. We define the function to shuffle the labels of our joined table and take one value of our test statistic from that. We then simulated this function 5,000 times and displayed the results in the following histogram. Our observed value of the test statistic did not fall in a 99% confidence interval, and at a p-value cutoff of 1%, our p-value was 0.02%, thus confirming the alternative hypothesis that hip-hop is indeed more danceable than folk in the real-life population. And now, knowing that, let's move on to prediction.
Having established that there is a difference between the genres, we can now ask ourselves, how can we actually predict the genre of a song, understanding these differences? First of all, there are 2 different ways we have learned to predict in our class. The first of which is linear regression, and the second of which is k-nearest neighbors. Now, when choosing between these, it is important to realize that linear regression is actually better for numerical prediction and predicting numbers from other numbers, whereas the k-nearest neighbors method is better for predicting categories from numbers. And as you can see from the graph, it does hold true that there is a success rate of at least 0.7 for no matter what the number of neighbors. However, as you can see, around 38 neighbors, the success rate does tend to drop off to way below the general average. And this is because past this number, because there are more hip-hop songs in the sample than folk songs, hip-hop tends to overcrowd folk, and it tends to muddle the data, leading the prediction algorithm to guess hip-hop every time, just because it is dominating the folk songs in the category. In summary, in this research report, we tried to figure out whether genre is actually a well-meaning definition of songs or whether it is simply a human construct. And we came to conclusions that 1, hip-hop has a higher average danceability than folk, and 2, that there are more hip-hop tracks than folk, which could influence the results in multiple ways. One such being that the range of hip-hop tracks selected could just have a higher danceability than the range of folk tracks selected, but in the actual population, this might not be true. Then, moving on to our actual hypothesis test, having established a p-value of 0.02 for 1% cutoff, we realized that simply the null hypothesis is false and the alternative is more likely to be true, with a 1% chance of the opposite actually being true and there being an error in our results. Having established a definite difference between the 2 genres, This led us to the question of whether we can actually predict what a song's genre will be based upon features such as danceability and the other features in the dataset. After having decided to use the k-nearest neighbors for prediction, for the reasons outlined previously, we were pleased with the success rate of our algorithm, as no matter the random sample, and with a reasonable amount of neighbors, the algorithm was almost always around 80% accurate for k from 1 to 38. Finally, looking at the limitations and bias of our report and our research, we could not apply our prediction method to all the genres of song, as initially we started looking at pop and hip-hop as these were our two favorite categories of songs. However, we soon realized that having there only been 13 pop songs, we could not use a prediction algorithm for pop and hip-hop, as hip-hop would always overcrowd pop for a very small amount of neighbors. So therefore, this is one limitation of our research, as we can only apply it to songs which have a similar amount of counts in the data. Overall, we realized that genre is indeed a good classification of songs, and there are multiple ways to define genre, and actually, genre can be predicted for a song. Thank you.